This lesson is about how computers store and display data. We're going to start off with talking about number systems, specifically the base 10 or the decimal system. So decimal number system. The decimal number system is 10 to the x power. So with base 10 or the decimal number system, single digits can have 10 possibilities, 0 through 9. Each position from right to left is 10 to the x power, starting with 10 to the 0 or the ones position. The positions right to left are 10 to the 0, 10 to the first, 10 to the second, 10 to the third, and so on. I'm going to write the actual value of each power below. So 10 to the 0 power, anything to the 0 power is 1. 10 to the first power, 10. 10 to the second power, 100. 10 to the third power, 1000. So let's start off with the most simple number we can think of. Let's start out with 1. So how do we encode 1 in the decimal number system? So 10 to the 0 power is 1. So it would be 1 in the first position. Next number we will code is 9. So how do we code 9 in the decimal number system? Well, we know in the first position we can put 0 through 9. So we're going to put 9 in the first position. The next number we're going to try and encode is number 16. So how do we encode 16 using powers of 10? So in the ones place we have 6, so I'll write that in the ones place. And then in the tens place we have a 1. So that is the encoding for the value of 16. The next value we will try and encode is 207. So in the ones place we have 7. In the tens place we have 0. And then in the 100s place we have 2. Next number, 1432. 1432. So in the ones position 2, in tens 3, in the 100s 4, and in the 1000s 1. So 1432. So that is the decimal system. And exactly in the same manner we can code in the binary system is how computers code numbers. So the binary number system. In the binary system is 2 to the x power rather than 10 as decimal. So in the binary system, we start with, just like we started with the decimal system, 2 to the 0th power, then 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. So we have 1, 2, 3, 4, 5, 2 to the 5th, 6, 7, so here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 positions, or 8 digits, and I'm going to write the value of each below. So 2 to the 0th power is 1, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd, 8, 2 to the 4th, 16, 2 to the 5th, 32. Notice each one is being doubled. 2 to the 6th power is 64, and 2 to the 7th power is 128. Okay, now let's write down a value and try to encode it. So the value for 1, how would we write the value for 1? So remember, 2 to the 0th power is 1. Now in the binary system, we can only use 0 or 1. And I will write that here. 0 or 1. So there are only two numbers we can use in the binary system in our encoding, 0 or 1. So we have the number 1 in the first position, and the rest of these we fill out with zeros. So that is, it has 8 digits, which we call a byte. It's 8 positions. And that is the number 1. The next number, 3. So how do we encode 3? So what I do is I start at the left, and I start with the first number that is less than the actual number that we're targeting. So we're trying to encode 3. So 4 is greater than 3, so we will start with the next position over to the right. So 2 to the 1 power. So we have the value of 2 plus 1 is 3. So that's how you encode the number 3 in the binary digits. And now I'm filling it out with zeros. Next number, 2. So do we have a position that equals 2? So 2 to the 2nd power is 4. It's too high. Move to the right. 2 to the 1st power is 2. That's perfect. So I'm going to fill everything out with zeros. So that is the byte code for the number 2. The next number, 5. So I will start with the number 4. So we have 4, and then I'm going to skip the 2, and so we have 4 plus 1 is 5, and I will fill everything else out with zeros. The next number, 15. I go to the 2 to the 4th position. We have 16. That's too high. So I'll start with 2 to the 3rd. So 2 to the 3rd, 1. So we have 8. And then 4, we have 12. And then 2, we have 14. And then 1, 15. So that is the code for 15, and we fill the rest out with zeros. Okay, the next, number 9. Here we have 8. Start with that. And we know 8 plus 1 is 9. Fill everything else out with zeros. Okay, the number 30. Two to the 5th is 32, so that's too high. 2 to the 4th is 16, so we'll start with that. 16. And then 8 is 24. And then 4 is 28. And then 2 is 30. So we're not using the 2 to the 0 position, and we complete the rest with zeros. So the next, 36. We have a 64, it's too high, and a 32, so we'll start with 32. And we know 32 plus 4 is 36, so we complete the rest with zeros. So that is the code for 36. And I think we have room for one more number to try out. So we'll try out 49. So we'll start with 32. 32. And then 32 plus 16 is 48. And then 1 is 49. And fill the rest out with zeros. So there we've gotten some practice in encoding binary numbers, and that was kind of fun. I actually enjoy that. And now let's move on to talk about the terms that we use for binary, and so this is the binary number system. So a bit is one binary digit. So a bit would be either a 0 or a 1. A byte is normally 8 bits. So it's 8 positions or 8 zeros or ones. That would be a byte. A byte or 8 binary digits can represent numbers I'll write this out. It can represent numbers from 0 through 255. So that is 256 numbers can be represented in a byte. The next, so we have bytes, now we have kilobytes. A kilobyte, kilobyte, is 2 to the 10 bytes. Or 1024 bytes. And I know what you were thinking. You were thinking kilo 1000. But remember, this is a binary. This is a base 2 system. So rather than 1000, 2 to the 10th power is 1024. And just for your information, there are 8,192 bits in a kilobyte. But if you said a kilobyte is 1,000 bytes, you would be close, but we try to be as precise as possible when we're working with computers. So that is kilobytes. And the next, a megabyte. So a megabyte is MB. And a kilobyte is KB. A megabyte is approximately 1 million bytes. Or to be precisely, it's 1024 kilobytes. A gigabyte is GB for gigabyte. And a gigabyte is 1024 megabytes. And then finally, just for practical reasons, we could continue on to higher numbers. But most people working with computers, you usually are not working with numbers over a terabyte. So a terabyte TB is 1024 gigabytes. So we're going to end our discussion about the binary number system, and it's very, very simple. Just a matter of recognizing that we're working with the decimal number system every day. It's very simple, and the binary system is exactly the same thing as the decimal system. The only difference is we're working in powers of 2 rather than powers of 10. Thank you.